Yeah, so thank you very much. The talk is in English. Let's start. So first, who we are. So I'm Ludovic Dubost. I'm the creator of XWiki. I'm currently the CEO of XWiki, which is a 60 people company. We'll come to that. But I'm also working more as a product owner for new features, new areas, and in particular AI and LLM in XWiki. And Michael?
Yeah, I'm Michael in German. I'm from Germany, so that's also why we're speaking English. And I'm a software engineer, and I'm the tech lead for LLMs in XWiki, basically.
First, what will we talk about quickly? What is XWiki? What is XWiki SIS? What is XWiki? Then what is the project we've been working on and for which we've done the evaluation? So it's called WASE, Wiki Artificial Intelligence Search Engine. It is a rack system inside XWiki. But that can also index other things. And then we will specifically talk about a framework that we've done, an evaluation framework to evaluate how well this system performs and how different LLMs or different configuration can perform better. So first, what is XWiki? So first, XWiki SIS is a company that's established 20 years ago. It's doing 100% open source. It's a French company, but we're also established in Romania. We have employees in Brazil, but also in Germany, like Michael. We have a company that's doing more than 3.5 million revenue. We also do research, so we actually have an activity level of up to like 5 million euros. It's an independent company, so we don't have any investors. We have full independence. We have 65 employees today, and we're very engaged in digital sovereignty. We believe that open source is key to keeping our freedoms, and we need to take back control of what software we run. And so we try to support that and to participate to that with the software that we're building. We're also part of a suite that's called Open Desk, done by the German government. If you don't know about it, go check it out. It's all about also this sovereignty issue. We live from services and providing support and also extensions for XWiki, and even SaaS. What do? We do the XWiki software. It's a knowledge management software, so wikis. We do wikis for organizations, so everybody knows Wikipedia, but we do it for inside company. One of our big competitors is Confluence. If you have a Confluence instance in your company, you can switch to XWiki. We have great migration tools, and it's much cheaper, and actually it's better. But we also compete with Notion or with the wiki of Teams, of Microsoft Teams, and so on. Everything's open source, and we have actually innovation in XWiki, which is what we call structured wiki. It's actually adding structure to your data so that you get more information about what the data is, and you get additional navigation capabilities in the wiki, and that's actually quite powerful. It's more similar to what Notion does with the Notion tables. We also do a second open source software. We won't talk about it at all here because we did the LLM system for XWiki. It's ScriptPad, it's Google Docs end-to-end encrypted. If you don't know about it, check it out. You can even use it for free on ScriptPad FR. And it's a quite fun tool to use, even for your personal usage, not only for work, but even like with your family. We have a lot of customers, large customers that are using XWiki. Even Amazon is using XWiki. It's their intranet. But we also have French ministries, large companies such as Lenovo, or insurance company like SCOR or SNCF or the city of Nuremberg. We have more than 200 clients. It's actually quite popular software. Okay, so that's about what we do and who we are. And now we're going to talk about WASE. Michael, your turn.
Yeah, so how we're going to get AI into this? So this was a research project funded by NGI Search that we're now looking to continue in XWiki regularly. The main thing that we developed as part of this project is an AI chat, as you can see here in the screenshot, basically that you can pop up a chat, also as we saw in the previous talk, where you can ask questions, and you can ask questions about content that you have indexed in your Waze, which is a RAG system. This can be content from XWiki, or we also have an API for external applications to add their own content. So you can combine content from different sources. Yeah, in the project we focused on open LLMs, more on that later, but in general you can use any LLM that has an OpenAI compatible API, which is basically everything nowadays. That's basically the standard. This chat is integrated in XWiki as extensions, but you can take this chat and actually embed it in any other application also, so this is actually designed to be embeddable. What's a bit particular about our project is also that it takes access rights into account. I will show in a moment how this works, so that you can only get answers about content that you can actually access. As part of the project, and that's the main thing we're going to talk about today, is we performed a benchmark of LLMs on question answering. This is what we are talking about today. We also evaluated a bit content summarization and content generation. I won't talk about this further. You cannot only use this chat via this chat widget, but we also developed a Matrix chatbot. So if you're using Matrix for your chat, then you can also directly address this chatbot in your chat. If you want to try it out, you can find it at this long URL. And you can install it on XWiki version 16.2 or later, because only these versions have a database that supports vector search.
Or you can just search XWiki LLM index, or XWiki LLM should get you to the pages.
Yeah, that's maybe easier. So how does it work? If you were here for the previous talk, you might have seen it a bit already. So what you do is you have a couple of documents that get into XWiki or are already in XWiki. You split these into chunks that are easily digestible by an LLM, because LLMs cannot use arbitrary large documents. And yes, context is increasing, but it's also not cheap. And also maybe not ethical to burn all these GPU hours. So we have chunks. We first index them directly for keyword search based on using BM25. And we also compute embeddings using an embedding model that can be run in XWiki or externally. And then we also index that. And this indexing, what we use in XWiki, because we already had it before, is Apache Solr. Then at query time, when a question comes in, this goes through our JavaScript API into XWiki, where we actually implemented an OpenAI compatible API. So we could also use another front end for that. And then we perform a similarity search here in step 2, where we do both a keyword search and a vector search, more on that later in the evaluation. This gives us context chunks, so chunks that are relevant to the question. Here we perform access control checks to see if the user can access these chunks, and we filtered those out that the user cannot access. And these access rights checks could also be directly at the other application. If this is content from another application, you can configure a URL that will be called with an API. So you can really integrate this with any application. Then we submit this to the LLM. As I said, this works with OpenAI, with Mistral, with self-hosted models, anything that speaks an OpenAI compatible API, and then this goes back. Did I mention this? So we combine the question with the context. I hope this was clear. That's why we get this context. So the LLM can answer the question. So
yeah, so we don't do a real demo because we don't have a lot of time, so we just put some screenshots. But I mean, if you want a real demo, you can come to a stand. We can show it for real. It exists. So here, for example, this is the chat interface that we have in XWiki. So this is more for a generative feature. So one thing in XWiki, what we chose for the generative AI interface, we chose to actually do a real chat interface, not just ask a question. It's gonna ask a question to the LLM, generate content, and put it in your page. We believe that it is good to refine your content so you can chat, and when you're happy with what the LLM has generated, you can actually either copy or directly include your content in your wiki page. So you can use the generative AI, the LLM, to enhance your writing capacities. Another aspect is that we have a prompt database. So actually, no, this is here. So if you look at this little box here, it allows you to choose some prompts, and these prompts can be configured in the wiki. You have a prompt database that can be shared with all the users in your wiki, so you can prepare prompts for your users so that they have the right prompts to how to use the LLM right. And so you can enhance this prompt database. We didn't provide a lot of prompts because we say, okay, let's keep that to the users, but we also plan to make some prompt lists based on what our customers tell us and users tell us. So one example in French, we indexed. So this is an example of ways. So we indexed in the wiki 3,000 documents. It created 6,000 chunks. Documents from a public website called Wiki Territorial, which is content from the fonction publique. So it's documents that are very corresponding to people working in French collectivities. A lot of legal documents, rules documents, and so on. And we asked some questions. So, for example, here we ask what is quel est le principe d'autonomie financière des collectivités, and we got a pretty good answer based on the content of the wiki, including some sources. Actually, so this little link here you can see which sources were selected by the RAG system. So if you open it, you'll get a bunch of links. And here, the LLM even included a link itself in the answer. So the LLM, actually, we asked the LLM, when you answer, please cite your sources, and it can actually add links inside the content to point out to the right source. So there is a lot of things that can be done into the presentation of the results, but this is what we have done at this point. You can ask to summarize. You can actually get an answer from the RAG, and you can actually ask the LLM to do more on it as you want. This is an example of the Matrix chatbot. So this is actually a real screenshot of Matrix, and where you can ask a question to the bot, and you get the answer, and you get the list of sources directly in your chat. So here it's a question about how do I change the memory settings of XWiki, and we indexed the documentation of XWiki for this. And actually, the chatbot is one of the reasons we decided to build the chat box, is because we believe that in the chat, there are actually additional features that could be built in. For example, one feature that we think is very interesting in the future is asking your chatbot, your bot, to summarize your chat conversation and save a wiki page with it. So that you can really keep a summary of a discussion that people had in the chat system. And we believe that this is interesting. And so the first step was to build a chatbot that could allow to build such a feature. Now on to evaluation.
Yeah, so now we have seen, okay, there are some great examples, but how do you know this actually works and actually does what we want? So why should we do another evaluation? There are tons of evaluations out there. Well, the question is, do you know the LLM works with your tasks? And what LLM should you choose? What is a good cost-quality ratio? What RAG strategy should you choose? And also, all these benchmarks that are out there, they are all biased in some way. And if you create your own benchmark or adapt it, you can influence these biases to be what you want to have. So how does the system work? Basically, the input is you have a set of questions that you want the LLM to answer. You have a set of answers that you expect. So this is like the reference you want to compare to. And of course, as we're doing RAG, you need to provide context documents. Then we execute the LLMs via ways. We do an automatic evaluation, so you don't need to look through all your answers, hopefully. More on that later. For this, we're using Deepeval. It's an open source evaluation framework, and it uses LLMs to judge the answers. And we're using GPT for O as a judge, and then we visualize the results using pandas and matplotlib in Python. And you can find this at this URL. So the questions we used is basically similar to what you saw in the matrix chat. It's basically XWiki technical support questions. We have questions of different difficulties. At the moment, it's just 11. This might not be enough. More on that later. So there are questions that are quite literally answerable from the documentation. So, for example, about receiving notifications about your own activity. There's a documentation where this is very explicitly explained, but we also include questions, for example, here, how to restrict attachment uploads, where you need to combine multiple sources because MIME type restrictions is explained somewhat different than the upload size, and it's also the documentation is not about exactly these MIME types. And then the last one is a trick question because the answer is no, you cannot. And this is something none of the LLMs could answer. They all tried to explain how to do it. So the expected answers, most of them were actually LLM generated, but manually edited and based on like whole documentation pages, like saying, okay, this is the documentation about this feature, and to see what the LLM can extract from that. In some cases, it didn't work. For the difficult questions, for example, there the answers are manually written. We also tried 3 different context collections, a small collection of the documents that are really needed to answer these questions, then a medium collection. This is the main collection we are using, which also includes some more general documentation and also explicitly similar documents to really test if the RAG works. And then in the large collection, we also added several years of public XWiki IRC logs that date back 10 years or so, so just add some noise. So let's first look at the results for this similarity search for the actual retrieval. So here I show results for contextual recall. This measures if the sentences are covered by the context, and we have here 3 different search types: keyword search, hybrid search, and semantic search, and we see basically no difference. And this, and this is a metric provided by Deepeval. We then made our own metric. This is really easy with Deepeval, and I can only encourage you to do this. And here we clearly see that semantic search doesn't perform that well, which also corresponds to what you see when you look at the results yourself. And this is basically a simple prompt that just asks the LLM if what the amount of information in the expected answer is that is present in the context. And we also have precision. Let's skip that for now. We then selected several LLMs. I don't really have time to go into the details, but basically we used some top closed LLMs for comparison, and then try to use some open LLMs that are at least usable for most commercial use, and ideally have weights available under an open source license. We would love to use something like Lucy. I'm really looking forward to that. There was a talk, 2 talks before about that. I'm really looking forward to that. Yeah, let's skip that. Skip directly to the results. So we have different questions. First, is the answer relevant? We have faithfulness, like is the context supports, and we have our own correctness score based on the expected answer. And the last one is this green one. Here you have the LLMs, and you really see that there is one, the smallest model, that doesn't perform well. Apart from that, the scores are very similar. And it's hard to see differences. This is really a problem, but what you can also take away is here, the closed ones are here at the top, but according to the scores, and if you look at the answers, it really shows the top open models, they are also quite good. If you look something like Mistral Nemo, it's really quite good. So there is a lot more to do. And that's it, basically. So
yeah, one aspect that is very important is that so at this point we evaluated the LLMs, we evaluated hybrid search, vector search, and only solo search, and we found that hybrid search had the best results,
yeah,
and
well,
solo search.
with
But
keyword search, it's
yeah,
really hard to tell from us, but you read that hybrid search is the
yeah.
best. That's also what we did for the last one, and yeah.
Yeah. But one of the key things we want to do with this evaluation framework is then to test different RAG strategies, because when you actually select your chunks and the way you combine them, how many you select, it's very difficult to know how you get the right the right best results. So it would be very interesting to see how results perform if you chunk by 2,000 character, or if you chunk by 4,000, if you select 5 or 7 and things like that. So different RAG strategy. If you modify and add more of the documents after the selection of the chunks. So that's one of the things we want to do with this. Everything's open source. You can check it out.
I assume we perhaps have time for one very quick question, if you have any. Otherwise, you are outside.
We also are on the XWiki stand, or just outside if you have questions.
Yeah, thank you very much.